You know how music has that incredible power to just hit you? It can completely bypass your logical brain and speak directly to your emotions.
I mean, think about it. Why does one song come on and boom, you just feel amazing, on top of the world? And then another tune, maybe just a few simple notes, can make you feel, well, deeply sad. How does that work?
The answer? The whole secret behind this emotional language isn't really in the notes themselves. It's in the space, the distance between them.
Okay, section 1, music's secret alphabet. It turns out that space actually has a name and a whole system behind it.
That space is called an interval. It's really just the distance from one pitch to another. You can think of intervals as the absolute fundamental alphabet of music. They're what musicians use to build everything: melodies, chords, scales, the whole shebang.
Section 2, naming the distance. So if intervals are the alphabet, how exactly do we read them?
Well, intervals can show up in two main ways. When you hear notes played one after another, like in a melody you'd hum along to, that's a melodic interval. But when they're played at the exact same time, stacked up in a chord, that's a harmonic interval. It's the same distance, it has the same name, but it creates a totally different feeling. Every single interval gets a two-part name. It's kind of like a first name and a last name. The first part is its quantity, and that's just a number. So if you go from C to E, you count the notes. C, D, E. That's 3, so it's a third. Simple. But the second part, the quality, that's where the real character comes in. It describes the emotional flavor. Is it major, minor, perfect? This is the part that does the heavy lifting.
And this shows you just how powerful that quality is. Look here, we've got a major third, the distance from C to E. It sounds bright, right? Consonant, kind of happy. But if we shrink that distance by just one single half step, that's one fret on a guitar, we get C to E flat. That's a minor third. And suddenly the whole feeling just shifts. It's darker, maybe a little melancholy. A tiny change in distance, a massive change in emotion.
And it's not just major and minor. You have other flavors, too. Some intervals, like the perfect fifth, are called perfect for a reason. They're incredibly stable and strong. But you can mess with them. If you raise a perfect interval by a half step, it becomes augmented, and it sounds tense, like it's stretching and needs to go somewhere. Lower it by a half step, and it becomes diminished, also tense, but with a more unstable, mysterious kind of vibe. Let's move to section 3, the feeling of sound. Now, I know this might all seem a bit mathematical, but here's the cool part. You don't have to count. You can actually train your ear to recognize these emotional flavors just by connecting them to songs you already know. This is basically a cheat code. Forget memorizing tables of half steps. Just use songs. That ascending jump in Happy Birthday, that's a major second, every time. The big heroic leap that opens the Harry Potter theme, that's a perfect fourth. And that simple open jump in Twinkle Twinkle Little Star is a stable perfect fifth. I promise, once you start to hear these, you absolutely can't unhear them. They're everywhere.
Okay, section 4, building with blocks. Now that we can actually identify these intervals, let's see how musicians use them as building blocks for bigger ideas.
I just love this recipe analogy. To build a happy-sounding C major chord, the recipe is so simple. You start with your root note C. Then you add the bright ingredient, a major third. Then you add the stable ingredient, a perfect fifth. And that is it. You've just built a major chord from scratch. So where does that recipe come from? It's not random. The ingredients, that major third and that perfect fifth, they're found naturally inside the major scale. A scale isn't just a boring string of notes you practice. It's the toolbox. It contains all the right intervals you need for that specific key. Section 5, how musicians really think. Now, theory is great, but how does all this stuff actually work in the heat of the moment for someone who's performing? So how do musicians actually think when they're playing? For some, like this person on Reddit, it's very direct. They hear the specific notes in their head, and their brain just translates that into note names. But for others, especially on instruments like guitar or bass, it's way less about names and much more about shapes and sounds. They're visualizing patterns on the fretboard. They just know what shape makes what kind of sound.
And eventually, a lot of players get to this point where the conscious thought just falls away. You enter this flow state. You instinctively know the sound, the feeling that any interval is going to transmit, and you just play.
And I think this quote really just sums up the ultimate goal for so many musicians. It's a seamless connection where you hear it in your head and it comes out of your fingers. All that theory, all those shapes, it's all become pure instinct. On to our final section, math or magic. We've laid out this whole system of rules and blocks, and it all seems pretty logical. But is it really that simple? What if it's less about math and more about magic?
This is where things get really interesting. A study in the journal Music Perception argues that intervals aren't really based on fixed physical laws. They are, and I'm quoting here, primarily psychocultural entities. What that means is, our feeling that a chord is happy or sad isn't some universal truth. It's something that we learn from the music and the culture that we grow up in.
This creates a fantastic tension. On one side, you have the ancient Greeks, like Pythagoras, who were absolutely convinced that music was cosmic math, built on pure, perfect ratios. But this modern research suggests it's more like a language. We're not born understanding what a minor third means. We learn its emotional weight by hearing it over and over in the context of the music around us.
And so that leaves us with this final lingering question. Is music a universal language of math, something that's literally hardwired into the fabric of the universe? Or is it more like a local dialect, a beautiful, emotional language that we only understand because we learned how to speak it?